Unit 9, Day 2 notes quadratic functions. Today we will be introduced to intercept or factored form of a quadratic function. If it's written in this format here, it is very, very easy to identify your x-intercepts. And I'll show you how to do that in just a second. The direction this one is going to open up. We can tell because in front of the parentheses, we have a +2, not a -2. Or I guess I should more accurately say a positive number rather than a negative. Vertex. Now, not as easy to identify our vertex here. There's a new formula that we're going to have to use in order to identify vertex if it is written in factored form. That is P plus Q divided by 2. And that will give us the x value of our vertex. Well, if we hit P and Q, those represents our x-intercepts. And our x-intercepts are what we see in parentheses. Note, nothing in front of the parentheses is going to impact the x-intercepts. So we're going to have an x-intercept at 3, 0 and -1, 0. Notice the pattern. I kept the numbers, I just reversed the signs. Okay, now that we know what P and Q are, we can answer the vertex here. So P, just use one of the x-intercepts, plus Q, in this case, -1. So we get an answer of 1. That is the x value of our vertex. In order to figure out the y value, what we're going to do is we're going to go back to our function here, and everywhere we see an x, we are going to plug in a 1. And then begin solving. And if we multiply all that together, we would get -8. That's our vertex, 1, -8. This is going to be, since this opens up, we're going to have a minimum, and we'll have a minimum value at -8. Axis of symmetry. X equals, it's the very first value, the x value, or the h, however you want to look at it, of your vertex. So x equals 1. Now, if we find our y-intercept, this is going to be very, very easy to graph. So in order to find y-intercept, take your function, and everywhere you see an x, we're going to plug in a 0. And then begin solving. 0 minus 3 is -3. 0 plus 1 is 1. Multiply all that together, we get -6. That is our y-intercept. Okay, now we know what our x-intercepts are. We know what our y-intercept is, and we know what our vertex. So let's just use those points, plot them, and then graph. I will start with the vertex. So 1, -8, go right 1, down about 8, roughly 8. X-intercepts next, right? 1, 2, 3. There's an x-intercept, and then we have another one at -1, a y-intercept at -6. So we could say right about there, and we just want to make sure we hit all those points. That one is now graphed, our domain of all quadratic functions. -∞, +∞, your range is going to start, in this case, with the y value of our vertex, so -8. And this one opens up. So from -8, we will go all the way to infinity. And that is example 3. Example 4. Now choose how to do it. Given the equation, find the specific characteristics. So we have to identify the vertex here. This is written in standard form. So in order to find vertex, we need to do -b over 2 times a, and that will give us our x value. Here, our a value is -1. Our b value is 4. And even though we don't need the c value, I just want you to be aware that it would be -1, that value right there. The a is going to be the number in front of x squared. I was actually pointing to the wrong one. It should be there, but it ended up being the same number, but whatever. Okay, so negative b, our b value is 4, so negative b over 2 times a. Simplify. Two. So that's half of our vertex there. 2 comma. In order to find the other half, let's take that 2 and we're going to substitute it into our function everywhere we see an x. Remember, whenever you have a negative in front of an x, this is how you need to set it up. And now I'm going to plug in a 2 everywhere I find parentheses. Order of operations first, simplify parentheses, which there's nothing we can do with the parentheses, so then take care of any exponent. Go ahead and multiply 4 times 2. This would multiply to get negative 4. Negative 4 plus 8. 4 minus 1. So our vertex is 2 comma 3. Since this one would open down, we have a maximum. It will never go any higher than that. So we have a maximum at 3. Here, find the axis of symmetry. Well, this is written in vertex form, and your axis of symmetry is going to be that number in the parentheses with the x. Keep the number, reverse the sign. X equals 2. Find the x-intercepts for this one here. Well, you can always check to see if you could factor. In this case, this one won't factor. So we're going to have to use the quadratic equation, which I will write that down again for you here in case you forgot. Okay, our a value is going to be negative 1. Our b value is 4. Our c value is also negative 1. Okay, now find the x-intercepts. So negative b and now I'm going to begin simplifying here. Okay, so 4 squared, that's 16. Now notice here, I have a negative times a negative times a negative, a negative times a negative times a negative. So we're ultimately going to be subtracting these numbers here. 4 times 1 times 1, well, that's just 4 over 2 times negative 1. Let's simplify a little bit further. 16 minus 4 is 12. The square root of 12, what does that reduce to? 2, 6, 2, 3. That's going to reduce to 2 root 3. So we can simplify a little bit more. Whew, I'm running out of room. Okay, and now note that all these numbers, not including the root, but all these numbers are all divisible by 2. So we would need to divide them all by 2. Negative 4 divided by negative 2, that'd be positive 2. Plus or minus 2 divided by 2, they cancel. Root 3. We do not have a denominator any longer. 2 plus or minus root 3, those are our x-intercepts. 2 plus or minus root 3 comma 0. Find the range of this function here. Well, this is written in vertex form right there. Our vertex is negative 3 comma negative 1. And as long as you know that value there, you can identify your range. This function opens up because the number in front of the parentheses is positive. So we're going to begin -1. And from there, we'll go all the way to positive infinity. Find the y-intercept of this function here, example E. Take the function and everywhere you see an x, plug in a 0. And begin to simplify. Parentheses first, 0 plus 3 is 3. Next, take care of the exponent. 3 squared is 9. Next, multiply. And now we can subtract. So our y-intercept is 0, 17. Find the direction that this opens. Well, let's identify where is x squared here. The number in front of x squared, is it negative or positive? It's positive. So it's going to open up. This one was not written in the correct order. It should be written like this. That's how it should be written. So maybe that's a little bit more clear as to why it opens up. Find the domain. Well, this is a quadratic function, so it's going to be all real numbers. And that's how we write it in interval notation. Let's move on to side 2. Okay, note that with example 5, it says use a calculator. So that's what we will be doing until we need to do otherwise. Use a calculator to find the maximum or minimum of the function and then to solve the function. So let's go to y equals, clear out any previous data, and then let's begin putting in this function here. Let's graph it. Okay, now that's kind of hard to see. We can see that the function is opening up there. So we need to adjust our window. This window is scaled +10 and -10 on the y-axis, -10 and +10 on the x-axis. So it looks like if I just had more scale up here where y is positive, that we would be able to see the function. So go to window, go to y max, let's adjust it to 20, and now graph. Okay, there I can see my function a little bit more clearly. Let's first identify the max or minimum value. This one, since it's opening up, it's going to be a minimum. We're going to have a minimum at that lowest point right there. So trace, second trace. Let's highlight minimum. And then now here's what I'm going to do. I see that my graph, the minimum right there, the lowest it will actually go, it looks like it falls in between. It almost looks like it's at 0, right? Where where x is 0. Here's where x is 0 here. It looks like our minimum's there. So what I want to do is I want to use the x-intercepts immediately to the left of 0 and to the right of 0. That would be -1 and 1. So now I'm just going to put those in. -1, enter, 1, enter, enter. So it looks like that y value there, that tells us what the minimum is. We have a minimum at 8.8. Real solutions? Well, none. We don't have any real solutions here. Real solutions are where your graph actually crosses the x-axis. This one will never cross the x-axis. Now, use your calculator for this function here. So let's put that function in. Graph it. I like my window to be adjusted back to the standard setting. So zoom 6 takes you back to the standard setting. The direction this opens, this is opening up. We can tell by looking at the graph. Vertex. Second trace. It's opening up. This is a minimum. So in order to identify the vertex, in this case, we need to select minimum. And now let's try and look at what our x-intercepts are. Our x-intercepts looks like there's one at -2 and 1. So let's use those numbers. First, -2, enter, 1, enter, enter. The x and y values, those are your vertexes or vertices. Vertex. What? -0.333, comma, -5.333. Is it a max or minimum at that number there? X-intercepts. Second, trace. Let's now find the zeros. This one here, it looks like it's at -2, but it's not quite. We can tell that it's not quite touching -2, but this graph falls in between the x-intercepts of -2 and -1. So let's use those numbers. -2, enter, -1, enter, enter. We have an x-intercept at -1.667. We have another one here. It looks like it's going right through where x is 1. So let's use the x-intercepts immediately to the left and right of 1, which would be 0 and 2. Second, trace 0, and now push 0, enter, 2, enter, enter. And we do. We have an x-intercept right at 1. Y-intercept. Second, trace. We want to use value here. And we want x to be 0, because anytime x is 0, that tells you what your y-intercept is. So 0, enter. 0, -5. That's our y-intercept. Axis of symmetry. X equals the very first value of your vertex. Domain. And range. That's the value of our vertex. And this will go all the way to positive infinity from there. Example 7. Write an equation given the following information. Vertex 4, -1, and we have a point at 2, 3. Okay, let's see here. Vertex 4, -1. Vertices have very special letters that designate that it's a vertex. That is H and K. Any other point, 2, 3, we can label as X and Y. Now, in order to, do you see how it gave us a vertex? They're trying to give us a hint. They want us to use vertex form to solve this problem. That's how you can identify, well, which one of these forms do we plug it into? Do we plug it into vertex? Do we plug it into standard? Do we plug it into intercept? Well, what are they giving you? That's the giveaway. You're going to have to memorize these equations. The formula for vertex is right there. Now we know all the values we need to substitute, because we have to figure out, well, what is A? Do we have a stretch? Do we have a compression? We plug all these in, we solve for A. That will then tell us whether or not we have a stretch or a compression. So let's start plugging them in. We want Y to be 3. We don't know the A value. We want X to be 2 minus the H value 4. Don't forget to square it. And then our K value, which would be -1. Now let's start solving. Parentheses first. Oops, I forgot my A value. Now let's take care of the exponent. -2 in parentheses squared is +4. Now watch this. Okay, this is A times 4, or 4A minus 1. Now add 1 to both sides. And now we can divide both sides by 4. So A equals 1. We kind of did a lot of work for nothing. So our final answer would be Y equals, since our A value is 1, we really don't need it, but I'm going to go ahead and put it there anyway. We did all the work. And then X minus the H value squared, followed by your K value. That's your answer. Okay, look at example B. Look what they have given us. 4, 0, 8, 0. Those are x-intercepts. So they want us to use intercept or factored form. Here's the formula for that. And then it gives us a random point, 3, 10. So we can say our p-value here, use any one of the intercepts. We're going to use 4 first. Our q value, let's use the other intercept, 8. X is 3. And y is 10. So let's start plugging everything in to see, do we have a stretch or a compression? We want y to be 10. X here we want to be 3, and then minus our p-value. X is still 3, minus our q value. That looks like an A, it should be a q. And then begin simplifying. Parentheses first. 3 minus 4 is -1. 3 minus 8 is -5. And now we have A times -1 times -5, which would be 5A. Yay! We have an A value of 2. So whenever we go to plug this in, we only need to plug in our A value and our P and Q values into factored form or intercept form. And that's your answer. Okay, now you're going to like this one. We're going to do the exact same thing that we did with the previous two. We're going to find the equation given a set of points, except they say we can use our calculator. Yay! I'm almost certain I don't use this very much because we're really not supposed to use calculators most of the time in math. But I'm almost certain that in order to do this, you have to at least have 3 points. I'm pretty sure that's the case. Okay, let's go to stat, edit. And then, oh, I have this one entered in. Okay, so watch this. You're going to want to make sure I labeled all of my X values. You need all of your X values in column 1. And then all of your Y values in column 2. And then make sure that the, like for example, here it was -1, -1. That needs to be in the same row. 2, -4 needs to be in the same row. 5, 29 needs to be in the same row. You got to make sure you have them in the right order. Okay, now that we have that, let's go back to stat, move right once over to calc, and then scroll down to quadratic regression. Hit enter, and then enter one more time. Now they have given us a value of 2, a B value of -3, and a C value of -6. So now we can plug these numbers into standard form. I'm going to write down the formula for standard form real quick. That's the formula for standard form. So now just substitute your letters, your numbers for the respective letter. You mean what I know. Yes, I said that intentionally wrong. Bada bing. Okay, write the equation of the parabola from the graph without a calculator. So that's what we're going to do. Note from the origin, this shifts up once. We're not going, our vertex does not move left or right from the origin. Then note it has another point here. So it looks like we went right 1, up 1. Then note here, we have another point there. So from this point to that point, it looks like we'd have to go right 2 and up 1, 2, 3, 4 to get to that point. If you remember from our last lesson, I showed you how to graph these using 1, 2, and 3. And then if you just square them, they're pretty easy to plot. This follows that pattern. So we don't have any stretch. We don't have any compression. So your answer is simply y equals x squared plus 1. We shifted up once from the origin. We're not going left or right any. So we don't need anything in parentheses here. Okay, this one here. There's two different ways we could go about writing this. I think the easiest one is vertex form. So left 2, up 1, 2, 3, 4. Our vertex is -2, 4. That's our H and K value. Okay. Now we have to check to see, do we have any sort of stretch or compression? So I'm going to highlight that point and that point. To get from our vertex to that point, we'd have to go right 1, down 1, following the pattern so far. To get to that point there, we'd have to go right 2 and down 1, 2, 3, 4. 2 squared is 4. So it follows the pattern. There is no stretch or compression. So we simply need to substitute these numbers into their respective letters, and we are done. We do not have a stretch or compression here. Oops, what did I forget? Did you catch it? I forgot to put a negative in front. We need a negative in front of this graph because it opens down. This example here, remember, we're not using a calculator. Our vertex is right 1, down 10. Sorry, H comma K, right 1, down 10. It looks like this is not following the pattern that I taught you last class. It looks like in order to get to this dot there, I would need to go right 1 and up 2. So since we have a change here, we can figure out a little bit more accurately. I'm going to give you a little formula here. A squared is equal to 2. Now, where did I get these numbers? I went right 1 and then up 2. If you wanted to use this dot, you could. A equals right 2 and then up 1, 2, 3, 4, 5, 6, 7, 8. Doesn't matter which ones you choose to go with. We're going to get the same thing. I'll just use this one here. Let's solve for a by first squaring what we have in parentheses. 2 squared is 4. Now remember, this is a times 4 or 4a. From here, I think you can see that we'd have to divide everything by 4. So a equals 2. We have a vertical stretch of 2. So we already know these are the values we're now going to have to use in order to write our final equation. We only need H, K, and A. We're using this formula once again because we are using our vertex here. So y is equal to there's your answer for that example. And then we'll end with example 9. Remember, they said at the top of this non-calculator, so we're not going to use a calculator. This one wouldn't require one. They have given us a formula here. They want us to figure out, based on this formula, how long does it take for the ball to reach its maximum height? So we're trying to find a maximum. We're trying to find how long to reach that maximum. What is the ball's maximum height? And then how long does it take the ball to hit the ground? So it's going to hit the ground at some point. Okay, here's how we're figuring it out. How about we start with how long does it take the ball to reach its maximum height? I'm going to write down the function, -2 t squared plus 8t. Well, we need to determine vertex. So that formula, once again, when written in standard form, is -b over 2a. B here is 8 and a is -2. So -b over 2 times A. Two. So we have a vertex at 2 comma something. So in order to figure out what this value is, let's take 2 and substitute it for t everywhere we see a t. Parentheses first, then exponent. Now I can distribute that -2 to the +4. Okay, we have our vertex. This is how long it takes to get to the maximum height. This is what the maximum height is. So we have a max at 8, and we get there in 2 seconds. How long does it take the ball to hit the ground? Let's take the same function here. Now, when you're solving for the ground, think ground 0. Take your equation, set it equal to 0. Here, notice that we have 2 terms that have a t in common. So we're going to start by factoring out, well, let me start over. Not only do they have a t in common, they are also both divisible by 2. So let's start by factoring out a -2 and a t. Now, if I took each of these terms and divided them by -2, don't forget the t, Flores. If I divided each of these by -2, that would leave us with t minus 4, set it equal to 0. Okay, now we have 2 factors here that we'd want to set equal to 0. Solve them both. We'd have to divide by -2 here. 0 divided by -2 is 0. Here we'd have to add 4 to both sides. You don't want the one that's 0 because that's where we started. We started at 0, but we hit the ground 4 seconds later. That concludes our notes. If you have any further questions, keep them to yourself. I'm teasing. Let me know. Come see me. Have a good day.